Today we are going to learn about geometric series and sequences. First, we're going to talk about geometric series. A lot of people don't know, but geometric is referring to multiplication patterns, while arithmetic is adding. With our geometric series, our formula is a little bit different than arithmetic. It's still S of n, but it's a1, parentheses 1, minus r to the nth power, all over 1 minus r. A1 is the same as last time. This stands for the answer to our first problem. So when we plug in our first value, what answer do we get? Ones are ones, and r is the rate. So it is our multiplicative process or part of the problem that's being multiplied again and again. N is the exponent that we're going to once again use. N is our number of terms. So when you look at a problem, the first thing I always like to do is solve for n. It's kind of the easiest part to get out of the way. So we have our problem, it's -3 to the I minus 1. When we're trying to solve for n, we once again look at our 8 and our 1. So n equals 8 minus 1 plus 1, which brings us back to 8. So we find the difference between the start number and the end number, so 8 minus 1, and we always add 1 to it. So n equals 8. That should be reviewed from the last lesson. Our second part that we're trying to find is our A1. So our A1 is the same as last time. That's where you take your starting number and you plug it into your formula. You'll notice that this time you're plugging it in for an exponent. So A1 equals -3 to the positive 1 minus 1 power. 1 minus 1 is 0. -3, just like any number to the 0 power, is positive 1. Hence, A1 is equal to 1. Next, we have to go ahead and find our r. The r should be fairly easy by looking within the parentheses. So whatever number is in the parentheses is your r. So we know that r is equal to -3. So we have our A1, our n, and our r. Since we need some room to work this out, we're going to go ahead and write our n up here. N equals 8, A1 equals 1, and r equals -3. Our process now is just plugging in to our Sn formula. Sn equals A1, which is 1, parentheses 1 minus -3 to the n power. Since n is 8, we'll put a little exponent of 8. And then in the bottom, it's 1 minus r. I like to use parentheses when I plug in, especially when I have a negative r value. To work this out, we would do order of operations, so we do parentheses first. So we do our exponents within the parentheses. -3 to the 8th power. When you're doing this in your calculator, make sure you put the -3 in parentheses. Is essentially 3 times itself 8 times. But you can do this in your calculator by hitting -3, and then hit this little upward arrow, kind of looks like a roof of a house, to the 8th power. And if you have a phone calculator, you might have to turn that sideways in order to do that. It is a really big number. It should end up positive, but we're going to drop our minus sign that was already right here. You can work out the bottom whenever you'd like, or you can just keep writing it. Either works. I'm going to go ahead and make that a positive 4, because 1 plus 3 is 4. If we take away our 1, or we do 1 minus 6561, we're going to get negative 6560, and then divide by 4. So this gets us negative 6560 over 4. 6560 divided by 4 is equal to negative 1640. So this is the sum of your geometric series. We'll go through another one just to make sure that we're really understanding. Once again, our formula is Sn equals A1 parenthesis 1 minus r to the n over 1 minus r, where r is the geometric rate, or the number that's in parentheses, n is the number of terms, and a1 is the answer to our first problem. Our example this time starts at n equals 1 and goes to n equals 10. Our first thing to find is typically n, because this is easiest. So we do our start number away from our end number, and we always add 1. So n equals 10. Next, we have to go ahead and find our r. That's the second easiest thing to find. Last time we found that in parentheses. In this case, it's not written in parentheses, but you can draw invisible parentheses around the 2, because when you raise something to a power, it's better if you put in parentheses. So the number that has the exponent is going to be your r. Next, we have to find a1, and then we will actually be ready to plug in. a1 is done by taking your start number and plugging it in to your equation. And I'm going to go ahead and use those parentheses. We are going to do order of operations, so we're going to do parentheses first. You can see that only a 2 is in parentheses, so that's fine. Next, we do exponents, which are not simplified yet, so we have to simplify that. 1 minus 1 is 0, so this becomes 2 to the 0. Since 2 to the 0, or anything to the 0 power, is 1, we can do negative 4 times 1, which is negative 4. So we now have our r equals 2, and our a1 is negative 4, and our n is 10. So we are ready to plug this into our formula. What we're going to do is we're going to write S of n. a1 is equal to negative 4. We know that r is equal to 2, and n is equal to 10. And everything is over 1 minus r, which is 2. we do the same process. We do parentheses first, so we'll do 2 to the 10th, because within parentheses, we follow order of operations. 2 to the 10th, once again, you can do that in your calculator. Probably will want to do that. We get -4 still. The bottom, we can slash and dash if you want to do that, or just do 1, take away 2. 2 to the 10th is 1024, positive. So we can do 1, take away 1024. Continue down here. That would be -1023. Multiply that times 4. You get 4092 divided by -1, which gets you your final answer of -4092. This is another geometric series. When you're looking at a whole bunch of numbers and you're trying to find out if it really is a geometric sequence, this time, as opposed to arithmetic, you're looking for a geometric ratio. So something that you multiply by to get from -4 to -24. You'd multiply by +6. -24 times 6 is -144. And -144 times 6 is -864. Therefore, this is a geometric sequence. So you'd write yes, geometric sequence, and you would write that the common ratio is 6. If you're presented with a problem such as this one, where 3 times 2 is 6, 6 cannot be multiplied to get 11, but if you did and you made it a decimal, it would be something like 1.83, and 18 divided by 11 would be times 1.64. These are all different numbers. So hence, this would be no, not geometric. We have now went over geometric series and sequences.